Hello friends, welcome back to another lecture of earthquake resistant design of structures. Right now, as we were discussing in the series of lectures, in the last lecture we have discussed regarding the static coefficient method, that is the static analysis method, right? Or it is also known as the equivalent lateral force method. In this particular lecture, we are going to discuss about the dynamic analysis of structure, that is the response spectrum method in the time history analysis. Now, as I told you earlier also, if you look at the sequence wise, then if you have a very simple structure, then and if you want to work on approximation, then in that case, the static coefficient method is a good method. But if you have a multi-story building and a regular structure with a regular frame, then in that case, it is advisable to go for response spectrum method. And if you have an irregular structure, and in that also you have a multi-story building, then in that case, time history analysis is preferred, right? So if you look at the authentication of method or the accuracy of method, then in that case, you can say that first comes the time history analysis, second is response spectrum method, and third is the static coefficient method, right? Now, response spectrum method and time history analysis method both are having the time component, that is a dynamic component, and that is why they are included under the dynamic analysis part. While the static force method is considering only the maximum values of peak response, and as a result of that that was included in the static segment, right? Okay, so when you talk about the concept of response spectrum method first, then in that case we can say that basically the concept is such that whenever an horizontal acceleration is generated at the ground level, right? That is, ground shaking is initiated or the earthquake force is initiated at the ground level. Then what happens is that these waves travel to the surface of the earth and they come in contact with the ground surface or with the structure is receding. Now, once they come in contact with the ground surface based on the soil profile that is there, whether it is of soft, medium, or hard type, then these waves are going to propagate and they are going to transfer the forces of these structures that are constructed above the ground. Right now, once that is happening, then as a result of that, what is going to happen is that the structure above is undergoing to go displacement, and based on the degree of freedom and the concentration of mass at the floor level, the maximum displacement and maximum amplitude is going to be calculated, right? So when you talk about response spectrum method, then we can say that it is basically a plot of peak response. This peak response can be calculated in terms of velocity, can be calculated in terms of displacement, or can be calculated in terms of acceleration also, right? So it can be a graph of acceleration versus time, it can be a graph of velocity versus time, and it can also be a graph of displacement versus time, right? With respect to the period of structural single degree of freedom system for a given accelerogram, right? Same thing is again highlighted over here, where you can see that for different time periods, in that case, in the first case, what is that was that the time period was empirical time period. So when in case of empirical time period, what happens is that the formula is given in the code predefined, so that formula is only to be calculated. Whereas in case of response spectrum, what happens is that considering the geometry of the structures, the time period is calculated. How the time period is calculated? Then first, the angular frequency of the structure is to be calculated. That is omega is equal to under root of k by m, where k is the stiffness of the structure, m is the mass of the structure. Once the angular frequency is available, then we can calculate the natural frequency. Natural frequency is given by f is equal to omega by 2 pi, where omega is equal to under root of k by m. And once the natural frequency is available to you, then what we can do is we can calculate the natural time period, and the time period formula is given by time period is equal to 1 by f, right? So once this value of angular frequency is available with us, then we can find out natural frequency. From natural frequency we can find out the time period, right? So various values of period of single degree of freedom structures, finding out the peak acceleration for given important earthquake acceleration and plot response versus the period. So this is the snapshot from the graph that is taken from the IS 1893 code that is given, where you can see that on the right hand that is where you can see that on the x-axis you have the time period, and on the y-axis you have the spectral acceleration values that are given by SA by G. Similar type of graphs can be produced for time period versus the velocity, and time period for displacement also. And as you can see that depending upon the type of the soil, the behavior of the structure is going to be there, because based on the amount of force that is going to be transferred to the structure is undergoing to go displacement and maximum response values are going to be obtained, right? So that is why three different curves are drawn. First is for the rocky soil, second is for the medium soil, and third is for the soft soil, right? Now, again, the other factor that is going to be there in consideration is also going to be the damping of this damping that is going to be there in the structures. So damping is dependent on the material of construction as well, right? So material of construction will be dependent on different types of possibilities are there, where the structure can be made from steel, other possibility is made from concrete, other possibility is that it is a masonry structure, maybe a wood structure, or maybe an earthen structure, right? But the possibilities is that in day-to-day life, for multi-story buildings, we either go for steel structures or concrete structures. And for low-rise structures, we may go for masonry structures. So in case of steel structures, the damping value is in the range of 2 to 5%. For case of RCC structures, the damping value is in the range of 5 to 10%. And for big structures, the value is also in the range of 5 to 10%. Steel structures are going to have less damping value available, and concrete structures are going to have more damping value available. Right? So depending on these damping values also, the response of the structure is going to vary. Now, again, the basics of the what you can say the response spectrum method, the calculation of forces is going to be more or less is going to be the same using the formulas that we use for the static coefficient method, that is VB is equal to H into W, and H is equal to ZISA by 2RG. But what the difference here is going to be is there that the period and mode shape of the structures are obtained using free vibration analysis and not empirical formula, right? So based on the response of the behavior of the structures with corresponding to every mass, we are going to have a set of eigenvalues and eigenvectors. And using these eigenvalues and eigenvectors, the time period is going to be found out, right? And that is the only major difference between the static coefficient method and the response spectrum method, right? Because in case of response spectrum method, the empirical formulas are not used to find out the time period, and that is what it makes it different from the static coefficient method. SA by G is obtained from the same response chart for all the modes separate, right? Distribution of forces at various stories is carried out using the mode shape and modal participation factors that we can that we are going to see in the remaining lectures of the upcoming lectures. And the response quantities, that is the BM and the SF, etc., are combined using the CQC method or complete quadratic combination method. That is, we have a couple of methods based on which you can calculate the forces, and these forces can be multiplied. So here an example just to understand, there is multiple degree of freedom system is shown where a G+2 structure is shown. So here in this case, we can see that the masses are concentrated at 3 levels, right? That is 1, 2, and 3. As a result of that, we can say that the structure is going to undergo 3 degree of freedom system. And when it is a 3 degree of freedom system, that means the number of mode shapes that are expected from the structures are also going to be 3. So mode shape 1, mode shape 2, and mode shape 3 are the 3 mode shapes that are going to be there. As I said, that corresponding to each and every mass, we are going to have a set of eigenvalues and eigenvectors, and based on which the mode shape diagrams can be drawn. Right? Next comes is the time history analysis, which is also included under the category of dynamic analysis. Right? Now, what is the difference between if you talk about the difference between the response spectrum method and the time history analysis method? Then first thing is that this results of time history analysis method are going to be more accurate for a given earthquake as compared to that of a response spectrum analysis method. Right? Why it is going to be same? Why it is going to be more accurate? Because the actual spectral acceleration of the site on which the particular structure is proposed to be constructed, that spectral acceleration is to be worked out, and for that site specific spectral acceleration only the structure is to be designed by considering the forces that are likely to act on it at the time of the earthquake. Right? So as a result of that, the values that we are going to use in case of time history analysis are going to, or the parameters of earthquake that we are going to use for calculation are going to be more realistic and more site specific as compared to response spectrum method. Right? Now what is going to happen is that dynamic analysis will be performed either by the time history method or by the response spectrum method. Now we are going to have 2 base shears. Why? First is from the static method, that is the seismic coefficient method, and second is from the response spectrum method. Right? So we need to compare that if the base shear from response spectrum method is less than the base shear from the seismic coefficient method, then it has to be multiplied by a scale factor. And the scale factor has to be multiplied and it has to be ensured that the minimum amount of base shear is going to be 98% or 90% or 80% to 100%, or in the range of 80% to 100% of the seismic coefficient method, right? So if these values of the base shear that is obtained from response spectrum is less, then also on the conservative side, it has to be done such that the scale factor has to be applied, and the scale factor has to be applied in such a manner that the resultant base shear is at least 80% or 80% to in the range of 80% to 100% of the value of base shear for seismic coefficient method. So the corresponding values of bending moment, shear force, and all these other values, story shears, and all these values, displacement, amplitude, all these values are to be multiplied by the scale factor, which we calculate accordingly. Right? Then this is comparison of pseudostatic analysis and dynamic analysis, right? So I think nothing much to discuss over here regarding this particular slide. Now the last thing that comes to mind is what is the code telling. Now this table that is shown over here, that was for IS 1893-2002 code, where dynamic analysis shall be performed for regular buildings having height greater than 40 meters in seismic zone 4 and 5, and for height greater than 90 meters in zone 2 and 3. That is for regular buildings. For irregular buildings, for height greater than 12 meters in seismic zone 4 and 5, and height greater than 40 meters in zone 2 and 3. And for industrial and frame buildings with large span and large height, right? But also recommend, though not mandatory, when height less than 40 meters in seismic zone 2 and 3, right? So this is a snapshot that is taken from IS 1893-2002, where the parameter was the height, and height was considered at minimum 40 meter height. If it is there, then any structure above 40 meter has to be designed or has to be analyzed for dynamic analysis method. However, in 2016 code, this particular clause has been modified, and now irrespective of the size of the building or irrespective of the height of the building, it is suggested that dynamic analysis should be performed in order to achieve accurate results. Thanks for watching the video. Thank you.